So I gave you guys a quiz on the reference angles and coterminal angles. I'll have to get one for Richard here. You didn't get one, right?
No.
I'll get one for you before we go here. Today we're moving in to something slightly different. Come on. Get my pen to work here. There we go. What do you look at this triangle and what sticks out as missing?
Right angle.
There's no right angle. This is not a right triangle. It is what we call an oblique triangle. Now remember, we discussed earlier that every triangle has 6 parts. Of those parts, there are 3 sides and 3 angles. If we know any 3, if we know 3, as long as it's not all 3 angles, we can find the rest. Even if it's not a right triangle. Now, when it's a right triangle, one of the 3 things we know is the right angle. So all we need to know is one other side and then one other part, period. One side and one other part, period. So what we're going to start out with today is we're going to look at that triangle, which I'm going to label A, B, and C for its vertices, for its angles. And remember, the sides are labeled by its opposite angle. So this side over here would be side little a, this would be side little b, and side little c. We've discussed before, if C is the largest angle here, which side has to be the largest side? Little c. That's why we name the sides by their opposite angle, not the one that touches them. Because the opposite angle is what determines its size. So the largest side is always opposite the largest angle. If angle B here is the smallest angle, what has to be the smallest side? Little b. By the way, just kind of a side note, if I were to tell you that angle C was obtuse, is it possible for A to be obtuse?
No.
No. A triangle obtuse, is over 90 degrees. And a triangle only adds up to 180. So you can't even have 2 right angles. If I know that one angle is a right angle, all the others have to be acute. The other 2 have to be acute. So I can only have one angle in a triangle that's 90 degrees or larger. So since C is the largest angle, that's the only one that could possibly be a right angle or obtuse in this thing. So anyway, based on that relationship, that the largest side is opposite the largest angle, we can use that relationship to relate the sides. But it's not, the side doesn't relate to just the angle, it relates to the sine of the angle. So that ratio, little a over sine of angle A, or side A over sine of angle A, just means any side and its opposite angle. That ratio is a constant within a triangle. So within this triangle, little a over the sine of angle A will be equal to the length of side B over the sine of angle B, which will be equal to the length of side C over the sine of angle C. So what does that mean? if I tell you that angle A here is 52 degrees, side A here is 32 feet, and angle C up here is 77 degrees. If we have two angles and one side given to us, this is the simplest case. If we have two angles and one side, there is only one possible solution. Which is a good thing. We don't like in math having multiple possible answers to the same question, right? We prefer one correct answer. First of all, how do I find angle B? Yeah, 180 minus 77 minus 52. Otherwise known as what, 51 degrees? So if we know two angles, finding the third angle is pretty darn easy. So now let's look at finding sides. We have side A. Do we know its opposite angle? Yeah, 52 degrees. That is a requirement for what I put up here, by the way. I didn't write down this name. This is what we call the law of sines. In order to use the law of sines, you must have a side and its opposite angle. So now what are we going to do with it? So we've got 32 feet over the sine of 52 degrees. We now decide which other side, what's the other side that we want to find at this point? B or C? One of you guys pick. B it is. That's going to be over the sine of its opposite angle. What angle goes in there? 51. Now, before we punch anything in our calculator, is little b going to be bigger or smaller than 50 or than 32? Smaller, because the angle is a little bit smaller. Not much. It's 52 degrees and 51 degrees, so it's going to be close to 32. So now we'll cross multiply and divide. This is just a proportion. So 32 times the sine of 51, close that parentheses, divided by the sine of 52, 31.56, we're going to call that. Again, not a whole lot different than 32, just a little bit smaller. Well then, how will we find side C? Yeah, we've got 32 over the sine of 52 degrees again. We're going to keep that. Now we're going to put sine C over the sine of 77 degrees. Cross multiply and divide. 32 times sine of 77. Make sure you close that parentheses again. Divided by the sine of 52. 39.57. Which makes sense. That is considerably larger than the others. That angle is considerably larger. We've solved that triangle. We found all its missing parts. So that was if we are given two angles and a side. I mean, realistically, if we're given two angles, we're kind of given all three, but we do have to work a little bit for the third one. So that's the simplest case. So let's look at the not so simplest case. You'll notice I'm writing down still given two angles on one side. Here, do we have a side and its opposite angle? We do not. Does that mean we're dead in the water? Not quite. Kind of does. It puts us in jeopardy. But can we find angle C? If we have two angles, remember we pretty much have all three. Right? That's 51 degrees. So it's not that we can't do it, it's just that we have to do one more step before we can do it. And now that we have that angle, we have a side and its opposite angles. We only have one side, so we're going to use the 40. What goes below it? Sine of 51 degrees. Somebody tell me, A or B do we want to find first? A. There's something Canadian today. Over the sine of? 61 goes with A. Cross multiply and divide. 40 times the sine of 61 degrees divided by, make sure you close up parentheses again, divided by the sine of 51 degrees. 45.02 feet. That was A. Well, now what? Equals B over. Perfect. So we still have the 40 over the sine of 51. Now we're looking for side B. So that'll be over the sine of 68. So 40 times sine 68 divided by sine of 51. 40 times sine 68 goes divided by sine 51. $47.72. Now, before we go any further, before we wrap up this question and move on to the next, do these answers make sense? Well, which angle is the smallest angle? 51. What's the smallest side? 40. That matches up. What's my biggest angle? 68. Is it across from the biggest side? Yes, it is. That doesn't guarantee we're right. It just stops us from making a really silly mistake, really careless mistake. We could still be wrong, but we're just not, like, obviously horrifically wrong. So that wasn't a lot more difficult. Let's move to something that may be a touch more difficult. We're given two sides and one angle. Looking at this one, do we have a side and its opposite angle? We do not. Does that mean we're dead in the water?
Probably not.
In this case, can we find any of the other angles? No, we cannot. We cannot use law of sine. Fortunately, we can use law of cosines. How do you keep a bunch of students in suspense? We're going to do the law of cosines tomorrow. I'm sure you're hanging on the edge of your seat waiting, right? It's kind of like TV. You got to set up the trailer, right? So yeah, that we cannot do. When we have two sides, basically here what we have is we have two sides, and we have the angle that's in between them. We cannot use law of sines there. So we'll have to use law of cosines. Again, by the end of this week, you will all know how to do that. Now this next one, I'm actually going to take the picture away. Because given the picture, it takes the issues out of it. If we are given two sides and one angle. So still that same situation. So one of the possibilities we just saw is you can't do it at all. The next possibility is, let's say I tell you that angle A is 29 degrees. We are not given angles B and C. I tell you that side A is 18 feet. Side B is 43 feet, and we're not given side C. Let's draw, now based on that information, let's try to draw a triangle. We're not given the triangle, but we're going to draw it based on what we were told in the problem. So I put it in gray. It's not black given, it's in gray. So A is 29 degrees, obviously not drawing the scale. A is 18 feet, B is 43 feet. Do I have a side in its opposite angle? Oh yeah. 18 over the sine of 29. Now I only have the other side, so 43 has to be used here. It's going to be over the sine of B. Now, when we are looking for an angle, what we're really finding here is the sine of an angle. So there's going to be some additional steps after we do the cross multiply and divide. So we're going to cross multiply. Sine of 29 times 43 and then divided by 18. 29. Yep, sine of 29 times 43 divided by 18. I got 1.158. Now that's the sine of angle A. What'd you say? Yeah, the sine can't be over 1. If I try to inverse sine them, right now what I found was the sine of angle B. To find B, I'd have to do an inverse sine. If I do second sine of that answer, my calculator is going to cuss and swear at me. Say, quit. It's not telling me to quit on life and go home and give up. It's just saying, quit this problem. It ain't going to work. Is that? Why did that not work? Well, because sometimes what we're given here is the angle 29 degrees. So that's 29 degrees. And we're given this side here is 43 feet. So we know it's 43 feet. We don't know how long this side is. It extends out here somewhere, right? We do know that this side is 18. What it's saying is, even if that side went straight down, 18 feet would not be enough to reach back down to the bottom. Does that make sense? This is only an issue when there are two sides and one angle. And the side opposite the angle is shorter than the other side. Now that doesn't mean it's impossible. I mean, it's possible for this side to be shorter and still make a triangle. But one of the possibilities is, if that side opposite the angle is shorter than the other side, it's possible possibility is he doesn't make a triangle. No triangle. So we're still dealing with being given two sides and an angle. I'm not going to rewrite it because there's a few possibilities that come out of this. Let's say I'm given the information. Angle A equals 31 degrees. Don't know angles B and C. Side A equals 21 feet. Side B equals 32 feet. And we don't know side C. So let's continue to draw our triangle here. So let's put in what we know. 31 degrees here, 32 feet here, and 21 feet here. Do we have a side and opposite angle? Yes. So why would that be a problem? We got what we need. Let's check this out. 21 over the sine of 31 equals 32 over the sine of B. So again, we're solving for the sine of B, not for B at the moment. So cross multiply and divide. So we use sine 31. Again, make sure we close that parentheses. Times 32 divided by 21. 0.7848. What that means is angle B is the inverse sine of that. Right? So do second sine, second answer. 51.70 degrees. So that's saying is angle B here is 51.70 degrees. Now there's a problem with what I just did. Oh no, this other one here would be, it's going to be more than 90, yes. It'll be bigger than 90. That'd be up to 6. That's not a huge deal. But the problem is, the way I drew this picture, that has to be 51.7. But if you recall, back when we did our unit circle for our trig functions, that sine of 0.7848, that's saying this length is 0.7848, right? That gave us that angle here of that 51 degrees. But there's another spot where the sine is still 0.7848, right over here. This angle would be the 51.7 degrees. So the actual angle of that would be 180 minus 51.7 degrees. So that'd be 128.30 degrees. Do we know whether that angle is really 51.7 or 128.3? We don't. I drew that picture. That angle looks acute in this picture, but I drew it. It wasn't given to me. That picture very well could be this could still be 31 degrees. This here could still be 32 feet. This could still be 21 feet. Again, it's an issue because this side that's opposite the angle is shorter than the other side. If this side were longer, there's no way it could tuck back under like this. Does that make sense? You either swing out here or tuck under like that. If it were longer, there wouldn't be room for it to come back under. So here, this angle would be not the 51, it would be the 128.3 degrees. So in order to make this work, we have to either have a picture that clearly shows us whether this angle is acute or obtuse, or we have to be told, oops, can't write it there, that's not an angle, that B is acute. If we're told B is acute, we know it's this possibility. If we're told B is obtuse, we know it's this one down here. Now, of course, from there, now that we know two angles, we can just subtract to get the third one, right? Subtract from 180, and we're good to go. Again, that's only a problem if the side opposite the angle is shorter than the other side. Still given two sides. So the problem with that one, of course, is that there's two possible triangles. Probably wondering, that first example I did, I made a point of saying if there's two angles on one side, there's only one possible result. Here, there was two possible results. There's two possible triangles unless we're told whether that angle is acute or obtuse. Or if that side's too short, there's no triangles possible. Now again, still on that whole given two sides and one angle. If I tell you that this angle is 31 degrees, I don't tell you angles B or C. If I tell you side A is 40 feet, side B is 32 feet, and we're looking for side C. Are there any issues here? Say no.
Absolutely not.
Why are there no issues here? You got it. This is the side that is opposite our angle, and it's larger than the other side. So in that case, there is only one possible way to draw this triangle. This angle here is 31 degrees. Oh, helps if I put the letters in there. This angle here is going to be the 31 degrees. This side's going to be 32 feet. This side's going to be 40 feet. Now, I'm not drawing the scale because we know that side's smaller. We know angle B. What do we know about angle B just by looking at this? It's acute and it's going to be smaller than 31, right? Angle B has to be acute because even if this one were obtuse, this one's obtuse, both of the other ones have to be acute, right? But we know because this side's smaller, we know this angle has to be smaller than this one. So this one has to be acute. So do we know a side and its opposite angle? Yes, we do. 40 feet over sine of 31 degrees. Let's find, well, we have the 32 feet, so we have to be finding the sine of angle B. So again, we're solving for that. Sine of 31 degrees. Close that parentheses. Times 32 divided by 40. 0.4120. And then, of course, we've got to do the inverse sine. B is equal to the inverse sine of 0.4120. So second sine, second answer. What'd you get?
24.33.
I concur. 24.33 degrees, we'll call it. This angle up here is 180 minus 31 minus 24.33. Otherwise known as 124.67 degrees, correct? Now, obviously, that's an obtuse angle, and I drew it acute, but it's okay. The numbers are still going to work. Finding side C. Well, we've still got 40 feet over the sine of 31 degrees equals C over the sine of 124.67, right? And here, since we're finding a side, there's no inverse. We just cross, multiply, and divide. So it shall be 40 times the sine of 124.67. Make sure you close that parentheses. Divided by the sine of 31. 63.87 feet. Again, before we move on to another problem, does this answer make sense? Biggest angle, opposite biggest side. Smallest angle, opposite smallest side. So yeah, nothing obviously wrong here. This time I'm going to draw the picture. Find angle B for me in your notes. How many of you guys got 38.17 degrees?
No.
Is that your final answer?
No.
No. So we get that the sine here is 0.6180, right? We do the inverse sine of that, which is 38.17. Look at this picture. Can that possibly be 38 degrees? No, it cannot. It is obtuse. Because it's obtuse, we must do the supplement. You got it. You got it. 141.83 degrees? Okay. And then, of course, this angle up here is found by subtracting those from 180, which comes up to be 20.17 degrees. And then you can find side C from there. What do we know about side C? I'm not going to find it right now because we are time to give you homework. But what do we know about side C as far as its length? Let me ask more specific. Is it longer than 48? No, why not? It's smaller than this. Is it longer than 24? Yeah. That angle's bigger than the 18, right?
Oh, okay.
So we know that C must be between 24 and 48. Now that's not narrowing it down a lot, but because that angle is between, this angle's smaller, this angle's bigger, the 20.17 is in between, that side has to be in between the other sides. All right. Well, time to have some fun. In the book, page 750, it's exercise 36-8. There's problems 1 through 12 there to work on. And on page 754, exercise 36-9. Problems 1 through 20. Let's just go with the odds in each of those. Alternate applications of this. I don't remember my trig functions. That's a right angle, right? Let's say this here is 34 degrees. And I know this side down here is 25 feet. What the heck? Well, I know this angle up here is 56 degrees because I subtract from 180. I don't remember my trig functions to figure out, I'll call this side A and side C. I don't remember my trig functions. Guess what? I can find side C. Sine of 90 degrees, by the way, is 1, but it doesn't matter. It still works. Yeah, so 25 times 1 divided by the sine of 56 degrees. 30.155. So I can do that all without using trig. I can use that law of sines on right triangles.
That's not bad at all.
No. Law of sines is a cool tool.